Hello students, welcome to Tuteetute. So as we have said already, so this 500 questions will complete from different subjects which are all previous year questions from any engineering services or any GENCO-TRANSCO questions or some of the PSU questions or very less gate model questions. Okay, so these are all previous year questions only. So we'll complete all the questions one by one with some concept base and with some explanations also. Okay, so if you understand these questions, then you can get some revision properly. So that's why we are providing these things daily. Okay, so anyway, let's start from the circuit subject. Okay, so the first question is, two inductive coils with self inductances L1 and L2 are magnetically coupled in series opposing and in series aiding respectively. The mutual inductance between the coils is M. The equivalent inductances in the two cases are respectively. Okay, so what they have asked, so when L1 and L2 they have connected in series, okay, so magnetic series connection and magnetically so parallel connection. Okay, so but they have some mutual inductance also between them. Okay, so then they are asking about, so what is the equivalent inductance? Okay, so the equivalent inductances in the two cases are respectively. Okay, so if you connect two inductances in series like this, okay, so two inductances like series in this, okay, so L1 and L2, so generally if no mutual inductance is there, then L equivalent we can give if no mutual inductance. Okay, so L equivalent equals to L1 plus L2 if you are connecting in series. Okay, so if you are connecting in parallel, okay, so two inductors, if you are connecting in parallel L1 and L2, then what you will get, L equivalent is equals to L1 L2 divided by L1 plus L2. Okay, so this is normal. Okay, so without M, okay, so without mutual inductance. Okay, so without mutual inductance. Okay, so without mutual inductance we got this. Okay, so for example between these two, if any mutual inductance is there, how you will get the complete equivalent inductance? Okay, so that's what they are asking. So let's consider now. Okay, so mutual inductance, with mutual inductance you have to consider. Okay, so when these two are connected in series, okay, so what is series connection? So side by side like this. Okay, so one end has to be connected with another end. Okay, so like this connected, but mutual inductance means there should be some dot polarity for this one, okay, or dot convention for this one. Okay, so what is this convention? Whether it is series aiding, this is series connection we know. Okay, so but this is series aiding or series opposing. Okay, so that we need to understand. Okay, series aiding or opposing, how we need to get means, if you send some current like this, any current, okay, any some current, so in this inductor, so this current is leaving at this dot. Similarly, for this inductor, the current is entering at this conductor. Okay, so at this inductor, so the current is leaving, and at this inductor the current is entering the dot, leaving the dot. Okay, so one is entering, another one is leaving. So we have to confirm whether this is aiding or opposing. Okay, so see, aiding and opposing both connections are possible. Okay, so what it is, if the current is leaving here and if the current is entering here, this kind of connection is called opposing. Okay, so opposing. Okay, so similar to this. Okay, so based on the dot convention we have to understand. Okay, so opposing. Okay, so that is opposing. So similarly, okay, if the dot is here and the dot is here, so if you send some current like this, okay, so then in inductor L1, okay, so current is entering, in inductor L2 current is leaving at this dot. Okay, so then we have to confirm this is also opposing only. Okay, so this is also opposing only. Okay, so next, so these are the two opposing connections, right? Okay, so what is aiding connection? Aiding connection means if dot is here and dot is here, L1 and L2, so if you send some current at the dot entering, at the dot entering, okay, so current will go like this, right? Okay, that means at the dot entering, at the dot entering, so this is aiding. Okay, so aiding means, so what is aiding? Aiding means supporting. Okay, so aiding means supporting. Similar to this, another connection is also possible. Okay, so that is nothing but if the dot convention is here, okay, for L1 and L2, if you send the current, some current, okay, so at this dot current is leaving this inductor, at this dot current is leaving this inductor. In this case also we have to confirm as aiding only. Aiding means supporting, okay, so this is supporting, okay. So if this is a opposing, okay, so opposing, what is the L equivalent? So that will be equals to L1 plus L2 minus 2M. This is opposing, so total mutual inductance, total equivalent inductance will be decreased, okay. So this is L equivalent L1 plus L2 plus 2M because it is aiding, okay, so aiding connection, okay. So that we can even derive these things also, but for now, okay, so we have to remember directly these things, okay. So we have to remember these things directly. This is a series connection, okay, series connection, understanding series connection, magnetic series connection, okay, so connection, okay. So magnetic series connection, that means two inductors we have connected in series, magnetically also they are connected, okay. So because mutual inductance will be present between these two, there will be mutual inductance between these two, there will be mutual inductance, okay. So like that we have to understand, okay. So this is series only, but what they have asked, they have asked about parallel also, okay. So what they have given, so are magnetically coupled in series opposing and in parallel aiding respectively, okay. So series opposing, okay, so series opposing means, so minus 2M we have to get, okay, either this option or this option will be correct, okay. So and what they have given again, parallel aiding, okay. So then we have to understand about parallel connection also, okay. So how we can understand the parallel connection? Parallel connection means the same inductors we have to connect in parallel, okay. So with mutual inductance we have to understand, okay. So anyway, so one inductor I have given like this, another inductor I have given like this, so and this is L1, this is L2, both are connected in parallel. For example, dot is here and dot is here, okay. So if you send some current like this, so based on the inductor values, definitely some current will go like this, some current will go like this. So that means, so this is nothing but, so this is aiding connection, okay. So aiding, at the dot current is entering, at the dot current is entering, this is aiding, okay. So similar to this, another connection is also possible. If two inductors are connected like this, L1 and L2, if the dot is here and the dot is here, if you send some current, at the dot current is leaving, at the dot current is leaving, okay. So this is also aiding connection, both are following same type of connection, that's why, okay. So this is aiding, okay. So similar to that, parallel, okay. So opposing also we need to check. This is L1, this is L2. If the dot is here and the dot is here, dot convention, okay. So current is entering, for example, current is entering here. So here also, if any two inductors or two resistors are connected in parallel, so definitely current will be divided according to their impedances or their reactances or their ohmic values, okay. So anyhow, so current will be divided like this. It may be more current or less current, no problem for us. At this dot current is leaving, at this dot current is entering. So what it is opposing, okay. So this is opposing, okay. So next, similar to this, another connection is also, okay. So like, so if two inductors are connected like this, okay, so this is L1 and this is L2, so dot is here, okay, so and another dot is here, okay. So this is also possible. So in this case also it will be opposing connection, okay. So whenever series opposing or series aiding, two types of connections are there. So what they are asking, parallel, okay, so not series, that is parallel, okay. So parallel aiding respectively, that means which type of connection they are asking? They are asking about this connection, okay. So let's see the options what they have given. L1 L2 minus m square divided by L1 plus L2 minus 2m, okay. So L1 L2 minus m square divided by L1 plus L2 plus 2m, okay. So similar options all are there, okay. So directly by seeing this one, so you will definitely do the mistake, okay. So directly we have to remember this formula. So whenever it is aiding, okay, so whenever it is aiding, L1 L2, okay, so L1 L2, so minus m square, okay, so L1 L2, so minus m square, so divided by L1 plus L2 minus 2m. This is for the series aiding, okay. So series aiding, parallel aiding, okay. So similar to this, whenever opposing is there, L1 L2, plus m square, okay, so plus L1 L2 minus m square divided by L1 plus L2 plus 2m, okay. So these are the two formulas. So how you have to remember this one? So numerator will be so always same only for parallel connection, L1 L2 minus m square, L1 L2 minus m square. In the denominator, okay, so if it is aiding connection means more value should be there, that's why in the denominator less value, L1 L2 minus 2m, okay. So here L1 plus L2 minus 2m there, L1 plus L2 plus 2m here, okay. So like this we have to understand, okay. So anyway, this is a series opposing and parallel aiding, okay. So series opposing, okay, so either this option or this option. So then parallel aiding, okay. So parallel aiding, what is parallel aiding? Aiding means denominator must be minus, okay. So option C is the correct one for us, okay. So anyhow, so once if you remember this concept, okay, so definitely you will not do mistake again. This is also one of the previous year question. Directly here formulas we are learning, okay, so they will ask the direct values, okay, with the values they used to ask in the examination, okay. So let's see the next question. In the circuit shown in the given figure, the current I through RL is, okay, so through the RL we need to find out the current, okay. So this is simple question only, so we can use any of the method, okay. So I will give you some certain analysis which method we have to apply in the examination, okay. See, two sources are there, we can apply the superposition theorem, okay. So there is no problem. So and we have one node here, one principal node here. Principal node means 1, 2 and total 3, okay. So 3 elements are connected, so more than 2 elements are connected, so that kind of node is called principal node, okay. So 3 elements are connected, so this is principal node, and here also 3 elements are connected, first one, second one and third one, okay. So 3 elements are connected, so this is also principal node. So I will choose this principal node as the ground node, 0 volts, okay. So and I will use this node as the node voltage V, okay. So the V is the voltage at that node, okay. So we can use like that, just simply we have to apply so the nodal analysis, okay. So V minus 420, okay, V minus 420 divided by 120 plus V minus 420, okay, so divided by 60, so V minus 0, okay, so this side is 0, V minus 0 divided by 30, okay, so divided by 30 equals to 0, okay. So this is the equation. If you solve this equation directly you will be getting, this is one method, okay. So this is using nodal analysis, okay. So using nodal analysis, so any circuit, okay, so any circuit you can apply the nodal analysis and within seconds you can get the answer, okay. So the thing is you have to just simplify this one, okay. So if you simplify, take 120 as the LCM for this one, V minus 420 plus so 2V minus 840 plus, okay, so 3V equals to 0, okay. So 3V equals to, so not 3V, it is 4V, okay. So 4V is equals to 0, okay. So 30 into 4 times it is so 120, that's why 4V, okay. So anyway, total it is 4V plus 2V, 6V plus V, total 7V is equals to 840 plus 420, what you will get? So 1260 you will be getting, okay. So 1260 will be the so total 7V, okay. So V equals to 1260 divided by 7, okay. 7 ones, okay, 7, okay. So anyhow directly, so we can take this value like this only, okay. So V equals to, okay, so 1260 divided by 7, okay. So this is the volts, and what we need current in this one, okay. So V minus 0, okay. So what is the current? I equals to V minus 0 divided by 30, okay. So this is the current. So anyhow V value we will substitute like this, 1260, so minus 0 divided by 7 is there, divided by 30, okay. So this is the one. So we have to, so 0 will be cancelled, and 7 into 3, okay. So 7 into 3 is so 21, okay. So you will get as 126 divided by 21, okay. So 21 once and 21 6 times, okay. So 21 6 times or 5 times, okay. So 21 into 6, 6 times it is. Okay, so directly 126 you will be getting. So answer will be 6 amperes. Okay, so this looks like a little bit long method, right? Okay, so because the values are like that, so you will be getting little bit of long. Okay, 6 amperes will be the correct answer, but no need to solve using like this only. Okay, so we can use different method. Okay, so let's see, this is 420 volts and this is 120. Okay, so this is 420, this is 60 ohms. So what you have to do, you just need to do conversion of this voltage source into current source. How we can do means, so any voltage source in series with resistance can be transformed as a current source in parallel with same resistance. Understand? Voltage source in series with resistance can be transformed as a simple current source in parallel with same resistance. So what you will be getting, so 420 divided by, so 120, that will be the current source value in parallel with, okay, so in parallel with 120 ohms, like this you will be getting. This is the current source. Okay, so 420 divided by, so 120, what you will be getting? Okay, so let's be like that only. Okay, so later we can simplify. Similar to this, another current source also we can make. Okay, how? 420 divided by 60. Okay, so 420 divided by 60, that will be the current source value here, 420 divided by 60, and as parallel to this another resistance 60 ohms we have to use. Okay, so and we have 30 ohms here. Okay, so directly we can put that 30 ohms here. Okay, so here only we need the current. Okay, so we need the current here. Okay, so anyhow two current sources are connected in parallel. Okay, so this is 420 by 120 amperes, so this is 420 divided by 60 amperes. So we can combine these two and make it as a single current source. Okay, so which has the value of 420 by 120 plus 420 divided by 60. How it is plus? Because both are in the same direction, that's why we are using the plus. If one is up and another one is down, so then if this direction is up, we have to follow this one. Okay, see, direction of this and direction of this is same, so we have used plus 420 by 120. This is also 420 by 60 plus it is. Okay, so like this we have to use. So then 120 in parallel with 60. Okay, so these two are connected in parallel, right? These two resistances are connected in parallel, so what you have to get? So 120 into 60 divided by, so 120 plus 60 is nothing but 180. Okay, 60 ones and 63s, 3 ones and 3 fours, 40 you will be getting. Okay, so this is the 40 ohms of resistance. Okay, so 40 ohms, and here already 30 ohms of resistance is there. Okay, if you simplify this one, so you will be getting 840 plus 420 is nothing but 1260 divided by, so 120. Okay, so 1260 divided by 120, so this is the one. So and this is the current value in amperes. Okay, so current value in amperes, they are asking about current in this one. Okay, so what is the total current here? If you simplify this one, so you will be getting, so this is the total, so 6. Okay, so 6 twos. Okay, so 6 twos and 6 ones, 21 by 2. Okay, so 21 divided by 2 means it will be 10.5 amperes. Okay, so here 10.5 amperes is there. Okay, so how much is going here? How much is going here? If you use the current division, we need current here, so this is I. Okay, so I equals to, okay, so we will be using like 21 divided by 2 only for easy calculations. Okay, so 21 divided by 2. Okay, so into, if you want current here, okay, so we need to use the opposite resistor, 40 divided by, okay, so 40 plus 30, 40 plus 30 means 70. Okay, so like this we have to use. Okay, so 21 into 4 is nothing but, so 84. Okay, so 84 divided by 14. Okay, so 84 divided by 14, 6, it is 84. Okay, so 6 amperes. See, for explanation it may take little bit more time. Okay, so because I want to explain you about parallel connection, how current will be divided in the parallel connection, and we are learning about okay, so conversion of voltage source into current source. How we are converting? Any voltage source in series with resistance can be transformed as a single current source in parallel with same resistance. Okay, so and similarly parallel, okay, whenever two resistances are connected in parallel, how we have to do? Okay, so whenever two current sources are connected in parallel, how we have to do? Okay, so anyhow you will be getting 6 amperes as the answer. Okay, so like that we have to solve. Okay, so let's see the next question. an ideal current source has 0. Okay, so they are asking about ideal current source. Okay, so ideal current source. Internal, okay, so internal conductance, okay, so internal resistance, voltage on no load, ripple. Okay, so they have given some options here. Okay, so we need to find out the correct answer for this. Okay, so what it is, ideal current source. Ideal current source means, so generally a current source means its internal resistance, it must be connected in parallel to this. Okay, so internal resistance must be connected in parallel to this. Okay, so this is the current source value of Is, this is the internal resistance of Rs. Okay, so directly we can answer that. Okay, but we have to learn some points. Okay, so this is the current source, which is generally Rs, internal resistance is connected in parallel to this. So then what we have to do, this is ideal. For example, it is ideal. How much current will be going here? Whatever current it is, if you connect some load, all the current must go to that load only. Okay, so no current should come like this. If no current should come means, what is the Rs value? No current should come. That means, so here it has to be open circuit. If it is ideal source, okay, if it is very good source or ideal source, so there should not be any current coming to like this. How current cannot come? If Rs value is a very high value. Okay, so if Rs value, okay, so if Rs value is very high, okay, so very high, then source will be, okay, so source will be ideal. That's it. Understanding? So source will be ideal it is. Okay, so source is ideal if Rs value. Okay, so what is the value? If high means, what is Rs value? It will be infinity ohms. Okay, so it must be for practical sources or for the good sources, it will be good source. Okay, instead of ideal, so we can call as good source, good current source. Okay, so anyway, Rs value is infinity generally. Okay, for a ideal current source. Okay, so for practical current source, it will be very high value. Okay, so like that we have to understand. Okay, so an ideal current source has 0. Okay, they are asking about 0. Here resistance is infinity. Resistance is infinity means, so 1 by resistance. What is 1 by resistance? So 1 by resistance is nothing but conductance. Okay, so conductance. Okay, what they have given, internal conductance. So internal conductance is 0 means internal resistance is infinity only. Okay, so option A is the correct one. Okay, so previous SPDCL question it is. Okay, so SPDCL question they have asked, so from the internal resistance concept. Okay, so let's see internal resistance, what we can find out. Okay, so for practical, okay, so practical voltage source. Okay, so practical voltage source, for practical voltage source, internal resistance Rs, okay, so internal resistance Rs will be practical. Okay, so practical voltage source, it will be minimum. Okay, so minimum or less value. Okay, so R very less. Okay, so very less for practical voltage source. Okay, for ideal voltage source. Okay, so for ideal, okay, so not ideal, ideal voltage source only. Okay, so for ideal voltage source, okay, for ideal voltage source, internal resistance value will be 0 ohms or short circuit. Okay, or short circuit. So next practical, okay, so practical current source. Okay, so practical current source. Okay, so internal resistance Rs, it will be so very high value. Okay, so very high value. Okay, so for practical current source, very high value. For ideal current source, okay, so for ideal current source, okay, so for ideal current source, so Rs value will be infinity ohms, or instead of infinity ohms we can use it as open circuit. Okay, so infinity ohms means open circuit. Okay, so this is the complete all details. Okay, so generally for the any voltage source, how we have to represent voltage source in series with resistance. Okay, so this is the representation of voltage source. Okay, so this is Vs and this is Rs. Okay, so this is voltage source. Okay, either this is DC only. Okay, so we have used the DC only. Okay, so we are not considering a AC circuit here. Okay, for understanding. Okay, for practical current source. Okay, how it is current source value of Is in parallel with Rs. Okay, so like this it will be. Okay, so this is the current source representation. Okay, so we can use current source. Okay, so these are the things from this question. Okay, so see these four. Okay, so this table, so if you understand, then you may get one question like this. Okay, so these type of questions, they are definitely giving in all examinations. Okay, so next question, what is the current through the 2 ohms resistance for the circuit as shown below? Okay, so these model questions are very common even in the gate examination also. See what they are asking. So the 2 ohms resistance. Okay, so current through the 2 ohms resistance they are asking. Okay, so current through this one they are asking either any direction. Okay, so they have not mentioned any direction, so let's consider some direction. Okay, so we need to find out the, so this current means we have some dependent source here. Okay, so what is the dependent source? If here V voltage will come, here 6V voltage will come. Okay, so that means the voltage source, how it is voltage source? So the plus and minus will represent it is a voltage source. How it is dependent source? It is, so this kind of symbol. Okay, so rhombus kind of symbol. So that means it is a dependent source. If it is independent source, there will be circle like this. Okay, so this is independent. Okay, so this is independent voltage source. This is dependent voltage source. Okay, so on what it is dependent? It is depend upon some voltage V. Where is this V? Here. Whatever voltage you will be getting, so that voltage you will be getting here also. Okay, so that's what they have given, and we can understand one thing. See here, so here 20 volt is there between these two terminals directly. That means between these two terminals 20 volts is present. Okay, so across this 5 ohm 20 volts is present, means how much current will be going? 20 divided by 5 directly. Okay, no other elements are there. Okay, only this 5 ohm is there. So 20 divided by 5 means 4 amperes will be going like this. Okay, 4 amperes. So based on this one, we can use any one loop analysis. Okay, so this loop I will just calculate. Okay, that means KVL equation I will be writing. Okay, see here minus 2 plus I am going, so I am writing minus 6V. Okay, so V is not the so unit. Okay, so it is a symbol here. Okay, V is a symbol. Then plus. Okay, so plus some current will be going like this. Okay, so definitely some current will be going, but we know the voltage already V. Okay, so we know the voltage already V here, and here what is the voltage? 20. Okay, so plus 20 is equals to 0. Why equals to 0? Why equals to 0? Because loop is closing, there is no other element. Okay, that's why. So even why to take like this? Okay, so you can take even this also. Okay, you will get the same. Okay, so then it is 5V minus 5V is equals to minus 20. Otherwise 5V is equals to 20 you will be getting. So V equals to 4 volt. Okay, so V equals to 4 volts. When V equals to 4 volts, what will be the current here? 4 divided by 2 is nothing but 4 divided by 2 is nothing but 2 amperes. So they want this amperes only. Okay, 2 amperes will be the correct answer. Okay, so whenever dependent sources are coming, okay, so you have to use some certain methods. Any one method you have to use to get. Okay, so either KVL or KCL. If KVL KCL possibility is not there, okay, so that kind of problems also we will solve. Okay, whenever some difficult problems will come, so from the dependent source, definitely we will solve using different methods. Okay, so next question, the coupling between two magnetically coupled coils is said to be ideal if the coefficient of coupling is, okay, so coefficient of coupling means so K. Okay, so coefficient of coupling means K. Okay, so how we have to represent this K? So generally the mutual inductance between two coils can be represented as, so M equals to K into root L1 L2. Okay, so m equals to k into root L1 L2. Okay, so that means what is the k value? M divided by, okay, so m divided by under root L1 L2. Okay, so this is the value of k. If the two coils are coupled perfectly, then mutual inductance will definitely match this. If perfect coupling, okay, so perfect coupled, okay, so coupled, okay, so then so m equals to under root L1 L2, so this will satisfy. That means what is the k value for perfect coupling? So k value is equals to 1. Okay, so anyhow, so it will not be more than 2 generally. Okay, so if it will not be more than 1 generally. If it is getting 2 means then we have to use external methods to make the so coupling coefficient k greater than 1, like that. Okay, so 0.5 is possible, 0.8 is possible. So generally for the k, the values of k, so it will be maximum of 1 and minimum of 0. Okay, so if 0 means there is no mutual inductance. Okay, so if 0 means there is no mutual inductance, there is no coupling. Okay, so if 0 is also possible, 1 is also possible. This is also one of the bit they have asked previously many times. Okay, so anyhow, answer for this question is 1. Okay, so the next question. So root L by C has the dimension of, okay, so this is important question. So asked in the previous IES examination, engineering services examination. So root L by C, okay, so this is, some students are having some problem with this one. Okay, so for that we have to remember something. So the time constant, okay, so the time constant generally for RC circuit, how you will be giving R into C. Okay, so R into C. So what is the unit? Seconds unit. Okay, so R is nothing but ohms, unit of resistance is ohm, and unit of capacitance is farads. Okay, so units of capacitance are farads. Okay, so let's leave it. Okay, see next one. So the time constant for so RL circuit is nothing but so L by R. Okay, so L divided by R. Okay, so here also it is seconds and here it is Henry divided by ohms. Okay, so Henry divided by ohms. So anyway, this is seconds, so we can just, as these two are time constants only, just for our analysis only it is. Okay, so if you consider RC equals to L by R, okay, so then you can consider L by R. Okay, so R square is equals to L by C. Okay, so then R we can represent as root L by C. Okay, so that means R equals to root L by C. Okay, what they are asking, root L by C they are asking. So directly root L by C we are getting as R here, so we can give it as ohms directly. Okay, so that means the dimension of they have given the dimension of resistance we can directly give here. Okay, so anyhow, whatever they ask, sometimes they will ask about L by R, sometimes they will ask R by L. Okay, R by L, what is R by L? R by L is nothing but 1 by seconds. Okay, so 1 by seconds we have to consider. Okay, so otherwise they may ask about so L by C. What is the unit of L by C? L by C is ohm square. Okay, so what is the unit of L by R? L by R is seconds. RC is also seconds. Okay, sometimes C by L they will ask. Okay, so C by L also they will ask. According to that we need to answer. Okay, whenever you get doubt, think about these two circuits and get the answer. Okay, so in exam we need to get the answer, that's why so we have made this kind of analysis. Okay, so otherwise why we have to make these two equal? Okay, this is for the RC circuit, this is for RL circuit, just for the analysis only. Okay, so maybe you may be thinking, right, okay, like from the control systems you can take the same formula and you can analyze, but it's okay, these two we can remember properly. Okay, so if you want to remember directly this one, okay, so R equals to under root L by C, you can remember even this. Okay, so if you are comfortable with control system formula there, then you can remember that. Okay, so like so Q factor and R value, zeta value, so these are all will be there, right? Okay, you can remember even that also. Okay, so anyhow answer for this is resistance. And the next question is the equivalent capacitance across A, B will be. Okay, equivalent capacitance they are asking between A and B terminals. So this question is very, very important. So this question they may ask from resistances also. Instead of capacitances, so they can give the resistances also. Okay, so for this one easily we have to make it like so this is node 1, this is node 2, this is node 3, and this is node 4. Okay, so we have to solve between these nodes. Okay, so we have to solve the circuit between these two nodes. Okay, so let's give it here node number 1, node number 2, node number 3, and this is node number 4. Okay, so node number 4. Okay, so node number 1 is nothing but A. Okay, so node number 4 is nothing but B. Okay, so node number 1 is A, node number 4 is B. Okay, so like this. So let's recreate again this circuit. Okay, so this one is between 1 and 2. Okay, so between 1 and 2 some capacitance is there. Okay, so let's take this one as the C first. Okay, so later we can change. So between 1 and 3 anything is there? Yes, another one is there. Okay, so between 1 and 3 C. Okay, so between 3 and 4 again. Okay, so another one is also there. Okay, so this is also C. Okay, between 4 and 2 another one is also there. 4 and 2 another one is also there. Okay, so any other between 2 and 3 another one is also there. Okay, so like total you should not count anything 2 times. If you want to count 2 times, otherwise make the numbering or notation for this one. This is A, B. Okay, so otherwise some other notations we have to give for this one. Okay, so anyhow, so A and B, between A and B we have recreated the circuit with the capacitance C. This is nothing but a bridge, right? If some current is going like this and C into C is nothing, it's not C actually, so we have to consider the reactance. Okay, so reactance or impedance into impedance is equals to impedance into impedance. All capacitances are same here, so definitely bridge will be balanced. When bridge get balanced, there will not be any current inside. Okay, so there will not be any current inside, so no need to consider. This will be virtually acting like a open circuit. No current can go inside from the middle element. Okay, see these two terminals are so input and output terminals like that. Okay, so if your current is entering like this, current is coming like this, in between whatever element is there, so that is middle element. In the middle element there will not be any current going. Okay, so no current is going means these two are connected in series. We can consider the circuit like this now. Okay, so these two are connected in series and these two are also connected in series like this between the terminals A and B. Okay, so between A and B, so these two C and C, C and C. So here because of the balanced bridge condition, so no current will flow inside, so I am representing with open circuit. Okay, so actually element is present but no current is going inside. Okay, whenever two capacitances are connected in series, so what is equivalent? C by 2. Okay, so don't think like 2C, both are connected in series, that is for the resistances. Okay, so both are connected in series means 2C you will 2R you will be getting for the capacitances or inductances. So here capacitances, right? That's why, so we need to get C by 2 and here also C by 2, and C by 2, C by 2 are connected in parallel, so then so you will be getting C by 2 plus C by 2. Okay, C by 2 plus C by 2. Okay, so what you will be getting? C by 2 plus C by 2, C you will be getting. Okay, so C is the answer for this one. So we have considered previously what is C, 0.1 microfarads, 0.1 microfarads will be the answer for this. Okay, so anyhow this kind of question already they have given like this. So with resistances, okay, so with resistances, so 3 resistances here and 1 resistance here and another resistance here. Okay, so both are all are having 3 ohms of resistances. You can try this question. Okay, so already previously, so if anybody has solved this one, no problem. Okay, otherwise you solve this one. Okay, so same method we have to solve, otherwise no need of any method also. Okay, if all the resistances are same, okay, then you will be getting so whatever answer you get. Okay, so just solve this one, after that you will understand. Okay, so here you may confuse about some things. Okay, so like series connection and parallel connection. When two resistances are connected in series R1 plus R2, you will be getting R1 plus R2 equivalent resistance. Okay, so equivalent. So when two resistances are connected in parallel, okay, so this is R1 and this is R2, so you will be getting R equivalent is equals to R1 R2 divided by R1 plus R2 Otherwise we have to use like 1 by R equivalent is equals to 1 by R1 plus 1 by R2. Okay, so like this we have to use. If capacitances, okay, so two capacitances are connected in series C1 C2, so then C equivalent is equals to, okay, C1 C2 divided by C1 plus C2. Okay, two capacitances are connected in parallel like this, okay, of same values, for example, then according to that you will be getting, okay, C1 C2, then C equivalent is equals to C1 plus C2. Okay, so like this we have to get. Otherwise this also we can make the general formula, 1 by C equivalent equals to 1 by C1 plus 1 by C2. Okay, so like this. So anyhow these are just series and parallel connection of elements. Okay, so however for the inductors we have already seen. Okay, so in the first question only, so we have seen already for the inductors how we need to check for the series connection and parallel connection. With mutual inductance also we have checked there. Okay, the next question, three resistors of 6 ohms each are connected as shown in the following figure. Okay, so they have mentioned as shown in the following figure, they have given the equivalent resistance between x1 and x2. Okay, these are similar. So let's consider, so this as x1. Okay, x1 already they have given, right? So that means let's consider node number 1. If this is node number 1, no element is present between these two, so here also it is node number 1 only. Understanding? Node number 1 only. Okay, so this is node number 2. Okay, so and definitely this is also node number 2. That means how many nodes are there here? Only 2 nodes are there. Okay, so there are no more nodes, only 2 nodes are there. See, everything completed. So that means, so between x1 and x2, okay, between x1 and x2 we have to recreate this network again. Okay, just like a previous question we have to recreate this. Okay, how we have to solve? Between, okay, so let's consider this one. Okay, so 1 and this is 2. Between 1 and 2, 1 6 ohms resistance is there. Now between 2 and 1 6 ohm resistance is there. This is 1, this is 2. Okay, so between 2 and 1, so we have another 6 ohms resistance. Between 1 and 2, another 6 ohms resistance is there. Okay, so you may get doubt. Okay, so here, so 1 and 1, between these two one line is there. What is this line? If you want, just for example, okay, so from here to here you have to give, there is no need of that connection. Okay, so because whenever some current will go, definitely that current will come like this, and this small wire will not make any difference to the actual circuit. Okay, that's why no need to draw this. So one node to another node, one node to the same node, without any other element we should not make any connection. Okay, so anyhow this is the complete connection. So then all 6 ohms are connected in parallel, then you will be getting 6 divided by 3. Okay, so directly we are giving 6 divided by 3 will be the answer it is. Okay, so that means 2 ohms will be the answer. Where is the option? Options are not present for this. So 2 ohms will be the answer for this one. Okay, how we got 2 ohms answer? 1 by 6 plus 1 by 6 plus 1 by 6. Okay, so that means, so total it is 1 by R equivalent is equals to 1 by 6 plus 1 by 6 plus 1 by 6. So no need to do all these things. Okay, so R equivalent equals to, so directly we will be getting, so this is so 2 ohms. Okay, so if we simplify also you will be getting, so directly we have to remember, if 3 resistances of equal values, remember the statement. Okay, if 3 resistances of equal values are connected in parallel, then what is the equivalent? So that resistance value divided by 3. If 10 resistances are connected in parallel, that resistance value, if same resistances, okay, if 10 same resistances are connected in parallel, then that resistance value divided by 10. If 20, like that. Okay, so if n number of resistances connected, like so many resistances are connected in parallel like this, of having same value, then equivalent will be that resistance value divided by n you will be getting. Okay, so like that we have to remember. So anyhow answer for this question is 2 ohms. Okay.